Okay, so the next portion for class 10 here, chapter 2, acids, bases, and salts. Okay, the TEST-2D portion, this will cover from question 65 to 71. So in this video, we're going to do certain questions, and in the next, complete it. Okay, you'll find this on your tuition note, pages 60 to 65, the tuition note that you have with you. And if you don't have the tuition note, you follow what I'm going to say as we go on. Okay. First question we'll do is the question 67 on the tuition note, which is list some acids or bases you can remember. That means we're going to deal with the common ones, okay, that you should know for this chapter, because this is acids and bases, right? So the common acids and bases, and fill in the blanks with their chemical formulae, means plural. Use lead pencil and eraser, so if you make mistake, you can correct them, okay? Now these are here 6 acids and 6 bases, very common ones. I advise you to memorize them because you will frequently need them, and this chapter, after all, is acids and bases, right? So it's only reasonable that you memorize them. Now just memorize the name and the formula. I think you can just get it along the way. So with your pencil, you will go here. Hydrochloric acid is the same chemical formula as that of hydrogen chloride gas, which is, you remember your starter and H plus and Cl minus, so 1 valency, that's it. Now usually we put AQ at the back, but then that's okay for formula. Sulfuric acid is H2, SO4. Follow me and just fill up. Nitric acid, HNO3. All these are very common acids and bases, so you need to memorize them. Then acetic acid, CH3, COOH. You need to memorize them to be comfortable with this chapter, because there are acids, bases. This chapter is. It's just like you need to know the names of your classmates if you want to be comfortable in the classroom, right? So similarly, you need to be comfortable with these names of acids if you're going to deal with this chapter comfortably, okay? Perchloric acid, HClO4. Here the only L is the only letter which is small letter, the rest are all capital, okay? Carbonic acid, H2CO3. Every letter there capital. So these are the 6 acids that at least you memorize them. Then potassium hydroxide, K1 plus OH1 minus. You can use the starter. Both valency 1, so that's the formula. Sodium hydroxide here, Na 1 plus, and then hydroxide ion, you know, is OH1 minus. Right, so these two first are the very famous bases. Okay, the 2 most famous bases would be these, I believe. So calcium ion, you know, CH2 plus. Then hydroxide ion, OH1 minus. Here valency is 2 and here 1, right? So these 2 here, while shifting to the lower backside of OH, we must put bracket because we know OH is a compound ion. By that we mean this ion contains more than one type of atoms. So in such case, if the valency you are shifting from top of Ca to the back of OH is a number greater than 1, which is 2, we need to put bracket, we know that. Now magnesium Mg2 plus, likewise hydroxide OH1 minus. 1 need not be shifted, 2 shifting time. Same rule as this, need to put a bracket and 2 there. Then copper ion, you know, is Cu2 plus. Hydroxide is OH1 minus. Again, same rule, bracket is a must because this is a compound ion and you're bringing a number greater than 1 from top here, which is 2 there. Ammonium ion, hydroxide, okay, this one, D. NH4 1 plus. This 4 is not at the top, at bottom, so the valency is only 1. Hydroxide ion we know is OH1 minus. So both valency 1, so the formula is NH4 OH. So I once again advise you to memorize these 6 bases and 6 acids. You'll get much more comfortable with this chapter, okay? As you will see even from the next question. So we'll next go to question 65 on your... you can pause the video and write it if you don't have the tuition note. If you have the tuition note, you can do this directly on the tuition note. It's there, right? The blanks are there to be filled up. So next we go to 65, okay? We'll go in this sequence, 67, 65, like that, because that way I think it will be easier for you. Next is question number 65. If you turn to your tuition note, if you don't have tuition note, it's textbook activity, page 29. Okay, so, and textbook, it is activity, if you want to write it down. 2.13, I think, yes, 2.13. This one you will find textbook, page 29. So open your textbook to that page as well. And then let me read the textbook question. Write the chemical formulae of the salts given below. They are potassium sulfate. So let us make it ourselves. We're just writing the thing here, potassium sulfate. So the textbook activity there is saying you write the chemical formula of these compounds. So put a blank and I write with your pencil, okay? Then B is, as you read the text, it says sodium sulfate, calcium sulfate. So I would number them as sodium sulfate, and then, okay, sodium sulfate, and next is calcium sulfate. So C, calcium sulfate, calcium sulfate. Then the next one is potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate. So D, magnesium sulfate, and then E is copper sulfate. Okay, if you don't have the tuition note, you write it on your copy. If you have tuition note, it's already prepared there for you. Okay, then sodium chloride, sodium nitrate, sodium carbonate. Sodium chloride, sodium nitrate, sodium nitrate, NiTrate, and then sodium carbonate, I think. So you prepare it like that, sodium carbonate, and then finally ammonium chloride. So I is ammonium chloride. So these are the compounds given in the activity there. The name is given to us. That means ammonium, I think chloride, yes. The chemical name is given to us. And the activity there is saying, using the name, you write the formula. Okay. Now, if you remember on your starter, we've done the ions, so remember them. Every chemical compound is such that it has two parts of the name. For example, potassium, first part, sulfate, second part. The chemical name, the first part is the positive radical. Okay. Or it is also called the basic radical because it comes from base. Bases come from here. And the second part is called negative radical, or it's also called acidic radical because acids are derived, their names are derived from this part. Okay. So positive, negative, everything is there. First part positive, second part negative. So if you remember your starter, potassium ion is K1 plus and sulfate ion is SO4, or do with your pencil, 2 minus. So the valency at the top is called valency. These numbers down are not valency, okay? They are the number of atoms in front. So there are 4 oxygen atoms, that means. But the charge here is called the valency. So 2 plus and here 2 minus and 1 plus. So this 2 and 1 can cancel. So this 2 will shift to the lower backside of K. So the formula for potassium sulfate is K2SO4. Likewise, sodium ion positive, Na1 plus, sulfate, SO4, 2. So 2 here, 1. So 1 may not be shifted. 2 will come to the lower backside of Na. Then calcium ion, CH-2 plus, sulfate ion, SO4, 2 minus. So you now notice that here valency is 2 and here also 2. Plus, minus, cancel. The plus, minus signs are not shifted, okay, while writing the formula. Means here plus, minus, only the numbers will be shifted. The magnesium, Mg2 plus. Sulfate ion, SO4, 2 minus. So 2, 2 cancel, so MgSO4. Copper ion we know is Cu2 plus. And sulfate ion is SO4, 2 minus. 2, 2 cancel, so this is copper sulfate. Formula CuSO4. This is blue colored salt, okay? the one put in swimming pool. You know, the swimming pool is blue because of this salt being dissolved in it. It's a disinfectant, like antibacterial. I mean, to prevent skin infection, I think they put in swimming pool. Now, sodium Na1 plus, chloride ion Cl1 minus, both 1, NaCl. This is the salt we put in our sabji every day, right? So sodium Na1 plus, nitrate ion NO3 1 minus. This 3 is the bottom number. The top valency is 1 minus, here plus minus. So 1, so that remains like that. Sodium ion Na1 plus. Then carbonate ion, we remember from our starter, CO3 2 minus. So here 2 and 1 enough be shifted. 2 will go to the lower backside of Na. So Na2CO3. Ammonium ion, NH4 1 plus. Then chloride ion, Cl1 minus. Both 1. So this is NH4Cl. So these are some salts. These are all salts, right? Salts. The activity there says write the chemical formula of the salts given below. These are common, very common salts, right? So we've written their formula. Now we will go to the next activity and question number 66, which we'll find on. So let me write down. Tuition note is question 66. If you don't have that, then it is activity. So turn to your textbook if you don't have tuition note. Activity 2.13. 2.13, same number, but it's now textbook on page 30. Okay, go to page 30. Let me read it for us from the text for those who don't have their tuition note. So you have here the salts. Later on, I'm going to use these salts for question number next parts. Okay, so next. There. Identify the acids and bases. The first, in the blue color box, the first pink dot. Identify the acids and bases from which the above salts may be obtained. Just now we wrote some salts, right? So those salts are derived from which acid and which base. So that's what we're going to do. Now, here, the first salt, go back to your note and find out what is the first salt in the page 29. Potassium sulfate, sodium sulfate. Okay, first one is potassium sulfate. So let me write down here A. You know the formula, so copy that from your first potassium sulfate. Okay, maybe derived. Just write like this. If you have the tuition note, do it directly on the tuition note. Maybe obtained. Okay, obtained from. Okay, the acid. Write like that. The acid. And then put a blank here. And base. And what base? Base here. Okay. So identify the acids and bases from which. Okay, then we can just make it slightly longer if you want. And base. Okay, now potassium sulfate. Please remember this. Salts. This is a salt. Salt are derived when acid react with base to give you salt and water. We know this from our previous videos. Every time an acid reacts with a base, salt is formed. In other words, salt is a compound or substance formed when acid and base react. So that's why this activity is saying, since this is formed from acid and base combination, which was the acid and which was the base from which this salt was derived. That's what they're saying. This will help you now here. Please remember this. Very easy if you remember this trick. May be obtained from an acid. Now please remember the acid always comes from the negative radical. Here, this salt has got K plus and this negative radical is SO4 2 minus. Please remember acids come from negative radical. Therefore, negative radicals are also called acidic radical. And the bases always comes from the positive radical. Therefore, positive radicals are called basic. Positive ions are called basic radical. Okay, keep that in your mind. If you want to write below that also, you can write it. Now, K2, since the acid comes from the negative acidic radical, which is SO4, this will give you the clue. So the acid is sulfuric acid, H2SO4. See, And the base comes from this one. Just now we did an activity for acids and bases. So you remember the bases. Common base there, potassium hydroxide. So K will give you the clue for base, positive. Negative will give you the clue for acid. That is why negative ions are called acidic radical, because they give the clue for acids, right? So we'll follow the same technique and go and do D. I will be rubbing out and do. You write the new one below. Second salt in the previous page 29, first activity was sodium sulfate. And the formula we have written is, so just copy it directly. This one. So now acid comes from negative part. So same one, H2SO4C. And from here, positive, the base will be obtained from there. The idea will come from there. So this time it's not K, it's Na. So NaOH is the base, like that. Remember, the base will be found from positive radical. The acid will be found from, the clue will be given by the negative ion. Okay, so next, C. If you go to page 29, again C is calcium sulfate. So you just copy the formula from your previous activity, calcium sulfate. And now obtained from the acid always come from negative part, means second part of the formula. So same H2SO4C and calcium. So this time it will be replaced by calcium hydroxide. So Ca and the valency is 2, so we need to put a bracket and 2. Next, D is magnesium sulfate. So that will be MgSO4, the formula. So the acid is still the same one, H2SO4, magnesium hydroxide now this time. The base will be from Mg, the positive part. And the valency is still 2, so same MgOH, floating 2. Then E. The E one is copper sulfate. So you write here CuSO4. So it's still coming from the same acid, SO4, H2SO4, and copper hydroxide now. Base will be from the positive. The clue comes from the positive, so copper hydroxide. Next, F. Okay, F is page 29. You can turn there or you're not. Sodium chloride, the famous salt that we use every day in our sabji while cooking, right? Without which it will be tasteless. The sabji will be tasteless. So the acid comes from the negative part. The negative part is this one now, Cl. The only acid that matches that is HCl, hydrochloric acid. And the positive come from Na. So it's the famous base. I would say the most famous base, or easily, in other words, easily recognizable base. Okay. So that is the one. Then G, the salt from the previous question, page 29, or your note, question note 65 is sodium nitrate. So sodium nitrate formula, whether we have written previously, is NaNO3, or even if you know the starter, you can write any, you will immediately view yourself. Obtained from acid, always negative part, means second part of the formula. So the acid that is matching NO3 is nitric acid, HNO3. So for this activity, you need to at least know the common 6 bases that we did with the first question in this video, right? And the base come from the positive part, Na. So this will be the same base, NaOH. Then GH, 2 more. H is here, sodium carbonate. So that will be Na2CO3. So acid comes from the negative second part. So CO3, the acid having CO3 radical is H2CO3, carbonic acid. And the base is still same NaOH, that one. Then last one here, the last salt in the first activity, second question we did is, I is ammonium chloride. So ammonium chloride formula is NH4Cl. As we said, acid comes from the negative part, this part. So Cl, the acid having the negative radical Cl is HCl. And the base having the positive radical NH4 plus is ammonium hydroxide. The common base. Just go to the activity first one. You will know the 6 common bases and acids, and this activity will not be hard at all. And then remember that acid, the clue, the idea will come from the negative part, in second part of the formula, and the base will come from the positive part, that is the fun part of the formula, will give you the hint or the clue for writing the formula for base, or the identifying the base. Okay, so this is question 66. So we have done here 67, 65, 66. So one more question, 68. important one. Now write it down. On if you have tuition note, you can do directly there, I think. And if you don't have, then this is found on activity 68. Okay, 68 is yes, activity 2.13, page 30. Page 30. Same you can write, but it's another activity there. So many activity, but this is useful for you, helpful. It will help you to understand acids, bases, and salts properly. Now let me read there on page 30, the blue box. The first box have 2 pink dots. The second pink dot is this question 68. Okay, so let me read. Salts having the same positive or negative radical are said to belong to a family, means same family. For example, NaCl and Na2SO4, these two salts belong to same family even though they are different salts. Why? Because both of them have Na, that means sodium. Therefore, they are called sodium salt family, same family. Similarly, NaCl, KCl belong to same family because NaCl, you see, NaCl, KCl, they are different salt. If you put in your mouth also, they will taste different. But they club in the same family because they have the same negative radical, so they are called chloride salts. Okay, like that, the question is saying. So we're getting the idea of what the question is trying to say. How many salts like this of the same family you can identify? So let us do from this activity, means the one that we have done on page 29 there. If you don't have to, should not turn to page 29. There are so many salts. How many family you can identify? So let us see that here. Okay, potassium sulfate, sodium sulfate. So let us all read out that one. So the first family that you can sulfate family. You can see that number 1. Let me read. Potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate. So all these are 1, 2, 3, 4, 5. They belong to the same family called sulfate family. Okay. Then number 2, another family you can identify. Okay, go to potassium. Negative part, let us do it first then. Okay, or up to you, positive also. You can start. Okay, better start like this. Just start from positive. Number 1, potassium. Find out which one have the other salts have the same radical, potassium, potassium like that. Potassium, sulfate, sodium, no. Third one, calcium, magnesium, copper, then sodium, sodium, sodium. Okay, only one, but we can say only one also, there is one family. So potassium salt. Okay, potassium salt. Okay, belong to the family potassium salt, one family. Second family, go to the next one. Sodium. Okay, sodium. Any more sodium? Yeah, down there, sodium chloride, sodium nitrate. So many sodium. So there you can say, according to positive radical, we are getting sodium salts also. Let us classify according to salt, potassium salts, sodium salts. Then next one, calcium salt, magnesium. So you can write there, calcium is there, so calcium salt. We can class as calcium salts also. There is there. The next one, magnesium is there, so magnesium salts. Magnesium salts. According to positive and negative radical, we are going to class the families. Find out how many types of families are possible. This question is saying. Then coppers. So we write the copper salts. Copper sulfate is there now. Copper salts. Then 6, copper. Any more positive? New one. Sodium is already done. Sodium nitrate, sodium carbonate, and ammonium chloride. So ammonium, one more positive. So according to positive, we have 6 of them, ammonium salts. Then according to negative, that's a 7. Go back there, sulfate. So sulfate family. This is the first name that you get, sulfate salts. Plus according to negative radicals, the negative part. Then next, sulfate. Next also sulfate. So not new. Next, chloride. So you write your chloride salts. Then next, number 9, you go there. Nitrate. So nitrate salts. Like that, we can get so many families. Nitrate salts. All those salts which have nitrate as a negative radical, sodium nitrate, potassium nitrate, all of them will come under same family. That means next, carbonate. That's new. So right here, carbonate salts. Carbonate salts. Then any more? Let us check out. Yes, carbonate salts, sulfate, carbonate, and chloride. I think chloride is already written here. Chloride. So there are total 10 families possible. So you can just write the final answer. Therefore, 10 salt families can be identified. Okay, from this question can be identified. So this is your activity. 10 salt families can be identified. So that is your question number 68. So once we have done that 68, 69 and 70, the question answer on the tuition note, you can read yourself and understand it. Okay, this concludes this video. We have a few more questions left that we'll do in the, especially 71 important question we'll do in the next video. Okay.